Hello everyone. Isn't arithmetic awesome? Like, the amount of fucking cool random formulas that you can find is just so incredibly immense, and this is one of them. So, apparently there's a formula for the sum of cubes, and it's this baby right here. And of course, this is, you know, the arithmetic sum of like 1 up to n, that of course you can rewrite as n times n plus 1 over 2. So you have a really practical way of computing sum of cube. But anyways, let us prove this. So how do we prove this? By induction, of course. So in this case, we firstly just have to prove a base case, and it is quite obvious that it works for 1 and 2. It's just 1 and then 9 on both sides. So now we make this our induction assumption, and so we assume this, and now we prove that it works for when n is n plus 1. So I would start with the right hand side. So what do we have then? Okay, we have 1 plus 2 plus all the way up to n, and then also plus n plus 1, and you have all of this squared, and we want to get to this point with a plus n plus 1 cube. So what I would do here is I would regard this as one group, one unit. Maybe we call it like A, and regard this as our B, and then do a factorization from this. So therefore we would have a squared plus 2ab plus b squared. So what would that be? Well, that would just be 1 plus 2 plus all the way up to n squared, that is our a, and then plus 2ab, so our b, which is n plus 1, and then time the thing we had before all the way up to plus n, and then we also add n plus 1 squared. So from our induction assumption, we can say that this part here is equal to the sum of cubed, so 2 cubed plus all the way up to n cubed. And for this part here, I will use the formula for the arithmetic sum. So you know that the sum of this, or this, is at least equal to n times n plus 1 over 2, right? So therefore, yeah, I can write it over here instead. So what would we have? Okay, we have 1 cubed plus 2 cubed plus all the way up to n cubed. And then, okay, we have 2 times n plus 1 times n plus 1 over 2. Okay, so the 2's cancel out, and we just get a n times n plus 1 squared. Yes, and then for the last part, we obviously have an n plus 1 squared. And here we see that, okay, then we can factor out the n plus 1 squared, so that we then have 1 cubed plus 2 cubed plus all the way up to n cubed, and then plus, if we factor out that, we get an n plus 1, so it's just plus n plus 1 cubed. And that is exactly what we wanted to arrive at. So proof concluded by the induction axiom, of course, and then we are done. So yes, that was everything. Make sure to check out the link in the description, and hope you appreciated the video, and I'll see you some other time. Bye bye.